Okay, so we're going to learn more about some theorems and postulates related to intersecting lines. This time, though, we're going to focus on parallel lines. So reminder that parallel lines are coplanar lines that do not intersect. And we're specifically going to look at when two parallel lines are cut by a transversal. That's a line that intersects two coplanar lines at two different points. So parallel lines, remember, will always have a marking on them that shows that they're parallel. Typically it's an arrow. And then a transversal is something that runs through two coplanar lines. Now a transversal can run through any two coplanar lines. They don't have to be parallel lines. But we're specifically going to look at parallel lines and talk a lot about parallel lines today. All right, so using this figure, we're going to talk about the following postulates and theorems. The corresponding angles postulate states that if we have two parallel lines cut by a transversal, then the pairs of corresponding angles are congruent. Now, corresponding angles are angles that are in the same position in relation to your parallel lines and on the same side of your transversal. So if I look on the left of my transversal, which my transversal is EF, and I look at the angles that are above my two parallel lines, so my first parallel line, I look at the left and above that parallel line, I have angle A. And if I look to the left of the transversal and above my second parallel line, that's angle E. Those are corresponding angles. And since we're dealing with parallel lines, those corresponding angles are congruent. Let's pick out another set of corresponding angles. Looking at that left side of my transversal again, if I look below my first parallel line, that's angle C. And below my second parallel line, that's angle angle G. Those are also corresponding angles. If I look at the right of my transversal and above both of my parallel lines, angle B and angle F are corresponding angles, and those would be congruent. And if I look below both of my parallel lines on the right side of my transversal, angle D and H are a pair of corresponding angles, and those would be congruent. Corresponding angles are only congruent when we're dealing with parallel lines. So if these two sets of lines were not parallel, then they would not be congruent angles. Let's move on to alternate interior angles. This states that if we have two parallel lines cut by a transversal, then the alternate interior angles are congruent. So, looking at my transversal, the interior angles are the ones on the inside of your parallel lines. So just these four. Alternate means it's on the opposite side of your transversal. So angle C and angle F would be congruent. And angle E and angle D are congruent. Okay, so then alternate exterior angles are the same, but they're on the outside of your two parallel lines. So angle A and angle H would be congruent. And angle B and angle G are congruent. All right. Same side interior angles. This states that if we have two parallel lines cut by a transversal, so this is my transversal still, the same side interior angles are supplementary. So looking at the four interior angles, which are the ones on the inside of your parallel lines, angle C and E are supplementary. and angle D and F are supplementary. And same side exterior angles, we would just be looking at the exterior angles, which means that they lie on the outside of my parallel lines. Angle A and G are same side interior angles because they're on the same, or same side exterior angles, sorry, because they're on the same side of the transversal, which means that they would be supplementary. And lastly, angle B and angle H would be supplementary. And those are your postulates and theorems. Now, with the corresponding angles postulate, that's the only one that's a postulate. We do not have to prove that. However, we will be explaining that postulate. The rest of these theorems would need to be proved. All right, so we're using the figure to the right for numbers 1 through 3. What pair of angles are angle 1 and 5? 1 and 5 lie on the same transversal, and they both lie above the lines that they're connected to. So these are corresponding angles. Are they congruent? No, they are not congruent because we do not have the transversal going through parallel lines. All right. Now, what about angles 3 and 6? 3 and 6 are both on the inside of the two lines, but on opposite sides of the transversal. So that makes them alternate interior angles. Are they congruent? In this situation, no, they would not be, because of the same reasoning as above. We do not have our transversal going through a set of parallel lines. And then 5 and 8. These are angles right across from each other. These are vertical angles. And vertical angles are always congruent. By the vertical angles theorem. All right, moving on to our next page. Looking at the figure, what can we conclude about angles 2 and 7? What type of angles are these? They are on the same side of our transversal. The transversal is the one that I highlighted in red, and the transversal goes through a set of parallel lines. They're on the same side of the transversal, and on the outside of those parallel lines, these are alternate exterior angles. Sorry, not alternate, I apologize, same side. They're on the same side of the transversal. And since we're dealing with parallel lines, angle 2 is congruent to angle 7. All right, angles 4 and 5. These are on the inside of your parallel lines, but on opposite sides of your transversal. So these are alternate interior angles. And what we know about them is that they're congruent. So angle 4 is congruent to angle 5. I completely apologize for number 4. They are not congruent. They are supplementary. Same side, interior or exterior angles are supplementary. right, angle 2 and angle 8. Opposite sides of the transversal and on the outside of the parallel lines. These are alternate exterior angles. And alternate exterior angles are always congruent when we're dealing with parallel lines. And then next, angles 3 and 4. These are angles that are right next to each other. These are a linear pair. And a linear pair, regardless of if the lines are parallel, a linear pair will always have our angles being supplementary. So angle 3 and angle 4 are supplementary. All right. Number 8 says to find the missing angles and name the type of angles. So this is my transversal. I have parallel lines, and angle A is above one of those parallel lines, or I guess to the left, and 48 degrees is to the left of one of those parallel lines. So angle A would also be 48 degrees because these are corresponding angles. By the corresponding angles postulate, measure of angle A would be 48. For this next one, same figure. B and 48 degrees are on the inside of your parallel lines and on the same side of your transversal. So these are supplementary angles, meaning if I do 180 minus 48, I get the measure of angle B, which is 132 degrees. This is by the same side interior angles theorem. All right, letter C. Looking at my transversal, both C and the 48-degree angles are on the inside of my parallel lines, and they're on opposite sides of the transversal. So that means that they're congruent by the alternate interior angles theorem. And then my next one, looking at my transversal, angle D and the 48-degree angle are on the outside of my parallel lines and on opposite sides of the transversal. So angle D is 48 degrees because they are alternate exterior angles. All right, moving on to my last page. We may need to split this up into multiple videos, so I'll try to get into 9 and 10, and then I'll work on the other ones in the next video. So for this, we only have these two parallel lines. If I cut by this transversal, E and the 54-degree angle are alternate interior angles. So E is 54 degrees by the alternate interior angles theorem. Looking at those same parallel lines, but this transversal, this 112-degree angle and F are not anything. They're not a pair of angles. But if I use the linear pair theorem and I do 180 minus 112, I get this to be 68 degrees. And now that 68-degree angle and angle F are alternate interior angles. So angle F would be 68 degrees. And there's two reasons. I used the linear pair theorem and I used the alternate interior angles theorem. All right, I'm actually going to have to do the next one in the next video.